All right, good morning. Today we're going to work on the Module 7 review for the test coming up. You'll need to open up you go to the Schoology course, and then it says Module 7 test review. You'll want to pull that up. You'll also want to pull up your student notes. It's important to be able to utilize both, and then these will both be resources that you can use on the test. So this is the Module 7 review over polygons and quadrilaterals. Those were the two main areas that we covered during this time. And so we're going to review some about what type of questions will be on the test. So this says answer each question, and each of these slides are going to kind of give you an area to go. So this says slide 11. That means I would go on my notes to slide 11, and this will be helpful in answering these questions. So the first question says, what is the measure of each interior angle of an octagon? So if I go to my notes, now slide 11 doesn't really have octagon on there, but if I go to the next slide, there's octagon. If I look at each interior, now it gives me the formula if I didn't have the information. Sides minus 2 times 180 divided by sides. So this would be 8 minus 2 times 180 divided by 8, or the work's already done. So in this case, what is the measure of each interior angle of an octagon? 135. What is the sum of the exterior angles of a 23gon? So again, looking at that table on slide 11, you look at the sum of exterior angles, you'll notice a common number all the way down through, no matter what size the polygon is. The sum of the exterior angles is always 360. What is the measure of each exterior angle of a heptagon? So again, looking at that table, the formula for each exterior is you're going to take 360 divided by the number of sides. And in this case, heptagon is already answered, 51.4. And the last one, what is the measure of the sum of the interior angles of a decagon? So a decagon has 10 sides. 10 minus 2 times 180 would give me the answer, or looking at the table one last time, looking in the column of sum of interior angles, a decagon is 1,440. And again, I got all of these answers right here. Sum of interior, 1,440. Each exterior of a heptagon, 51.4. So sometimes it's not about just exactly understanding the math. We want you to understand that, but it's also about understanding the resources. Okay, so this one says solve for x in the following figure. And if you go to slide 14, it gives you the steps on how to solve for interior angles. See, all these angles are on the inside. So step 1 says, find the sum of the interior angles. Now I can do this one of two ways. This has 5 sides. So on slide 14, it gives you the formula. It says sides minus 2 times 180. So if I do find the sum, this is step 1. Okay, I'm going to do 5 minus 2 times 180. That equals 540. Or you could just look at the table. Okay, you could just look at the table. Now step 2 says, okay, now you're going to take all of these angles, add them together, and set them equal to that sum. So in this case, I'm going to start at the top. 4x plus 5 plus 5x minus 5 plus 6x plus 10 plus 4x plus 10 plus 7x equals the sum of the interior angles that I just found. So you're just going to write all of these down. So I'm going to combine like terms. I'm going to highlight all of these x's here. Now I'm going to add all of these up. 4 plus 5 is 9. 9 plus 6 is 15. Plus 4 is 19. Plus 7, I get a total of 26 x's. And then I'm going to do the numbers. Sorry, that should be a 5 right there. 5 minus 5 is 0. 10 plus 10 gives me 20 equals 540. So if you get the setup correct, I think that's the biggest thing. That's the hardest battle, making sure that you have the correct sum out here, making sure you have all the angles written down. If you do that, I feel pretty confident in your ability to solve this. So I'm going to subtract 20 from both sides. Okay. 26x equals 520. And then divide by 26. X equals 20. 520 divided by 26 is 20. So you're going to go over here. Be sure and insert a copy of this. That way you can use this on the test. Okay. Now, this particular problem is a little bit different. So, we need either all the angles to be inside to solve this, or all the angles to be outside. And unfortunately, we have some angles inside and we have some angles outside. So what do? Well, we need to move a couple of things around or find more information. So I kind of redrew it here. Anytime I'm starting to have a question on things, I like to redraw it so I can kind of draw on it. These two angles are inside, and I'd rather move those to the outside somehow. A lot of people make mistakes, and they go 88 plus x plus 41 plus x, and then they'll continue writing these around, plus 63 plus 132. And that's going to give you the wrong answer. These need to be on the outside. So here's one of the things we know. This is a straight line, and we know a straight line has a measure of 180 degrees. So this missing angle is whatever I need to add to 132 to get 180. So in this case, it'd be 48. 48 plus 132 is 180. Over here, it'd be 117. 117 plus 63 gives me 180. So I no longer need those. So I can finish it out. Now, this says, look at slide 16. And if you look at slide 16, the first step is different for exterior as it is for interior. On exterior angles, the sum of the exterior angles always equals 360. So we don't need to do any type of calculation. We just know that this always equals 360. So again, I'm going to combine like terms. I have an x here and an x. So that's 2 x's. And then I have these numbers, 88 plus 41 plus 117 plus 48. That equals 294. So now again, I'm feeling pretty good. This is a two-step equation. It's something I'm familiar with. Subtract 294 from both sides. 2x equals 66. And then divide by 2. X equals 33. And I'm able to come over here and insert this into my notes. And we are good. Now, these next few questions are more about properties. It says, answer the following questions about properties of parallelograms, slides 18 through 29. So we're looking at these properties dealing with parallelograms, more specifically these types. So if it asks a question about parallelogram, I would look at these properties. So the first question says, what is true about the diagonals of a parallelogram? Highlight all that apply. They bisect each other. They are congruent. They are perpendicular. They bisect opposite angles. So looking at the notes, the only thing involving diagonals that is listed in the properties of a parallelogram is that the diagonals bisect each other. So it says highlight all that apply. There could be more than one answer, but there is only one answer for a parallelogram. So just kind of highlight it, and that's all we're going to do. Second question is very similar. What is true about the diagonals of a rectangle? So I'm going to find the rectangle in my notes. There it is. So again, it has the same properties as a parallelogram. So diagonals bisect each other. But it also says diagonals are congruent in a rectangle. So here, diagonals bisect each other. That's an answer. And they are congruent. So if it said a square, or if it said a rhombus, or if it said trapezoid, you would look at those particular those properties and then work on it as many as you need to highlight. Okay. This one, a rectangle is blank a parallelogram. It says use slide 19 to help answer this question. A rectangle is always, sometimes, never a parallelogram. Let's look at slide 19. So it's this family tree, I call it. Okay. So a rectangle is always, sometimes, never a parallelogram. Well, as we work down here, quadrilaterals can be sometimes, or quadrilaterals are parallelograms. Okay, as you go down, we're just making specialized quadrilaterals. Okay, so quadrilateral is a parallelogram, and then it breaks down into rectangles and rhombus, and then it breaks down all the way to a square. So as you go down, the rectangle is always going to be a parallelogram. A rhombus or a square is always going to be a parallelogram, the same way that they're always a quadrilateral. Okay, so in this case, a rectangle is always a parallelogram. But let's look at this next question. A rhombus is always, sometimes, never a square. So here is rhombus and square. A square is always a rhombus. Okay, they share the same properties. However, not all rhombi are square. Okay, not all the time. If you go the opposite way, it's only sometimes. So a rhombus is only sometimes a square. Not all of them, though. And then when you look out here, if there's any questions about kites or trapezoids, these are their own family of shapes. Okay. All right. So now we're going to start using some properties, these properties that we've been talking about. Solve for x in the rectangle below and use slide 24. Well, one of the properties, the specific properties of a rectangle is there are 4 right angles. So these corners are right angles. And anytime we hear the word right, that means they're 90 degrees. So to solve this, we know 10x equals 90. That's it. So to solve this, I'm going to divide by 10 on both sides. X equals 9. So that was very simple. 10x equals 90. Solve it. X equals 9. Because these corners are always 90 degrees. So again, pause the video. Make sure you insert that work so you can look at it later. Solve for x in the parallelogram below. Well, slide 21. This helps me because it says opposite sides are parallel. Okay, well, that doesn't help me set up an equation. It also says opposite sides are congruent. So these sides are opposite one another. They are the same. So to set up my equation, I'm going to say 2x equals 5x minus 18. Now, you can solve this in any way. You can move any of these that you want and just keep working around. I would probably move the 5x over to get the variables on the same side. So I'm going to subtract 5x from both sides. Some people would move the 2x since it's smaller. That's fine. You'll still get the same answer. Just a few more steps. So this is negative 3x equals negative 18. Divide by negative 3. X equals 6. All right. This next one. Find the length of the median of the trapezoid. Slide 31. So slide 31 says, to find the median, I take 1/2 of the first base plus the second base. Remember, these two parallel lines are bases. So I'm going to add the bases together and divide by 2. So in this case, here are the two bases. 54 plus 86. I'm going to add the bases together and divide by 2. So 54 plus 86 is 140. 140 divided by 2 is 70. So don't make these harder than they are. Sometimes they're relatively simple. Not looking for a whole lot. Okay, we have 2 more shapes we're going to look at. First one is find the missing parts of the kite, slide 35. And we need to figure out what is x, what is y, what is z. Well, remember the short diagonal kind of cuts these kites in half. Okay, so you have these, this part and this part. So these 2 consecutive sides are always going to be congruent. The same way on this side, these 2 consecutive sides. So if this side is 19, that means this side has to also be 19. Don't get distracted by the 18. We're kind of using this short diagonal as a boundary line. What is y? Well, if this side is 18, then this side has to be 18. And then we know opposite angles are congruent, and they're bisected by this diagonal. So if this half is 48, then this half has to also be 48. And the last slide, dealing with a square. And you can look at the properties on slide 28. But most of the properties of a square, all the sides are the same. The diagonals are congruent. The diagonals bisect each other. The diagonals bisect opposite angles. You have 4 right angles. The diagonals are perpendicular. So there's a lot of words written down. There's a lot of properties to a square. So let's do it one by one. What is the length of BC? Well, if this side is 35 and all the sides have to be the same, then this side has to also be 35. What is the length of AC? Now, this is the diagonal. I already clicked up the answer. So I know diagonals bisect each other. So if this half is 10, this other half has to be 10. And the entire length is 20. And since the diagonals are congruent, if this is 20, the other one has to be 20. What is the measure of DMC? Now be sure and follow my mouse. DMC. When the diagonals intersect here, they're perpendicular. And when we hear the word perpendicular, that means that all of these angles are 90 degrees. So DMC is 90. What is the measure of ABM? ABM. Well, we know that these corners are 90 degrees and that this diagonal cuts this corner exactly in half. It bisects it. So if the whole thing is 90, then what is half of that? 45. And the last one, what is ADC? ADC, that's its entire corner, 90 degrees. So be sure, look back on any of these problems. As long as your notes are caught up, that's the biggest part. This should help you out tremendously on the test. If you have any questions, let us know.